This is the first video in our second module studying fluids. In the previous module, we studied only static fluids. In other words, in the previous module, we restricted ourselves to studying fluids which were not flowing. In this module, we're going to be studying flowing fluids. We're going to begin in this video by studying a fairly simple example of a flowing fluid and asking a fairly straightforward question about that scenario. So here we have a pipe with a cross-sectional area A. We have a fluid of constant density ρ flowing through the pipe, and the fluid is flowing through the pipe at speed v. The question we would like to ask is this: what is the rate at which fluid mass is flowing through that red circle that I marked on the outside of the pipe? Let's put this another way. Just imagine that we have some pipe through which a fluid is flowing, and imagine that you take a red marker or a red paint and just mark a circle on the outside of that pipe. We want to know what is the rate at which fluid mass moves from the left side of that circle to the right side of the circle. To answer that question, we're going to look at a process where a blob of fluid starts out on the left side of the circle and then flows along until that blob is completely on the right side of the circle. So in the initial situation here, I have the forward face of the blob right at the position of the circle, but then the blob flows along. And in the final situation, I have the rear face of that blob at the position of the circle. So let's say that delta M represents the mass of that blob. And let's say that delta T represents the time that it takes for the blob to go from being completely on the left side of the circle to being completely on the right side of the circle. So if delta M is the mass of the blob and delta T is the time that it takes for that blob to pass through the red circle, then we can say that delta M over delta T is the rate at which fluid mass passes through the red circle. Let's call this quantity delta M over delta T the mass flow rate. Okay, so now we would like to try to get an expression for the mass flow rate in terms of the cross-sectional area of the pipe, the flow speed v, and the density ρ. We're going to do this by first getting an expression for delta M, then getting an expression for delta T, and then dividing. So first of all, what would be the mass of the blob? We learned in the previous module that the mass of anything would be the density of that material multiplied by the volume. So what would be the volume of this blob? Well, the blob has a cross-sectional area A, just like the pipe itself. Then the length of the blob would be L. So the volume occupied by the blob would be A times L. And we can then say that the mass of the blob is its density times the cross-sectional area of the pipe multiplied by the length of the blob. Second part of this is how much time does it take for that blob to completely pass through the red circle? Let's concentrate on that back face of the blob, which starts out over here. As we go from the initial situation to the final situation, that back face of the blob is moving at a speed v, and it moves through a distance L. For an object moving at a constant speed, how do we relate the speed, the distance traveled, and the time it takes to travel that distance? Well, remember that for an object moving at a constant speed, we can say that the distance traveled, in this case L, is equal to the speed times the time interval. From this, we can solve for the time interval delta t. That would be the length of the blob divided by the flow speed. And now let's put everything together to get the mass flow rate. The mass flow rate is defined as delta m over delta t. Here we got an expression for delta m. Here we got an expression for delta t. So let's put that all together now. So the mass flow rate, by definition, is delta m over delta t. We have seen that delta m is the density times the cross-sectional area of the pipe times the length of the blob. The time it takes the blob to pass through that red circle is the length of the blob divided by the flow speed. So rearranging a bit, first we cancel the L's between top and bottom. Now that 1 over V in the denominator flips into the numerator, and we have our formula for the mass flow rate. The mass flow rate is the density of the fluid times the cross-sectional area of the pipe times the flow speed. So to wrap things up, we ask the question, what is the rate at which fluid mass flows through some marked section of a pipe? That rate is called the mass flow rate, and it is given by the density of the fluid multiplied by the cross-sectional area of the pipe multiplied by the flow speed. In the next video, we're going to use our formula for the mass flow rate in a simple example problem.